Okay, problem 9. If you want my pathetic defense for doing this on Friday night, it's that my wife is out of town. She's on vacation in Europe, and she's coming back without me, I know. But she's coming back tomorrow, Saturday, so, Friday night, try to get things done. All right, anyway, or that's what I'm telling myself. Okay, so problem 9, we have a 6 amp current running through a wire for 4.5 minutes. Calculate the number of coulombs that move through the wire for A, and then B, the number of electrons. Okay. This is just unit conversion. And this is definitions of unit conversion, I guess. So for A, the current was, current was 6 amps, and the time was 4.5 minutes. Okay, so we have a current of 6 amps and a time that passes, I'm going to call it delta T, of 4.5 minutes. Okay, well, what is current? Current is the rate at which charge passes per time. Okay, this is current, delta Q over delta T. And let's just take this at 6, but let's also expand amps into more fundamental units. And an amp is a unit of current, so an amp is really a unit of charge divided by a unit of time, which means it's coulombs, and since we're using SI units, we know it must be seconds. Okay, 6 coulombs per second. So if we need to find a number of coulombs that pass through this wire, well, we really just need to find out how many seconds we have to wait for and multiply by 6, and there we go, right? So delta T is 4.5 minutes, which is also, let's see, 60 minutes per second, so that's 270 seconds. Okay, 270, sorry, seconds. And my mother, the European standard for drawing sevens is to do that. My mother does that, and she's completely American, born in California, lived here her entire life, nothing European about her, but she does that with her sevens. Weird. Okay. But I love her anyway. Okay, so the total charge that goes through then, pretty obviously, all we have to do really here is take delta Q is 6 coulombs per second times our delta T, which is 6 coulombs per second times 270 seconds. This is so much more detailed than you need, I'm sure. 420, is that 1620? Is that right? 6 times 70 is 420 plus the 1200. Yeah, okay. So delta Q is going to be 1,620 coulombs. And that's it for part A. Part B was how many electrons move through the wire. Well, that's not very hard. You take number of electrons. Maybe I'll call it, I don't know. N is the number of electrons, okay? And quite simply, the number of electrons times the charge on an electron, times the charge on an electron has to equal that charge that we had. So the number is going to be that our previous delta Q divided by negative E. Now, here's the tricky thing. We calculated a number of coulombs that pass. This is going to give us a negative number of electrons. And the reason why it's doing that is because, if we remember, here's a wire. If we have current going this way, we define current, in conventional notation as the movement of positive flow. Or, I'm just the movement of positive flow, sorry. Movement of positive charge. So if positive charge is moving to the right, that means negative charge is moving to the left, and we know it's the electrons that are negative and are actually moving, okay? So that's why we're going to get a negative number for number of electrons, because if this current here is the current going this way, and if we divide by the true charge on an electron, which is negative E, we'll get a negative number, and that means electrons are going this way instead of they're going left instead of right, okay? But that's the only thing to worry about there. So this is going to equal, I switched to brown for no particular reason, 1620 coulombs divided by the charge. I'll make it whatever. I don't care if it's negative or not. I mean, you just have to. This is where you have to use common sense and say it's not a negative number of electrons in the past. It's a positive number. They're going the other way. All right, 1.6 times 10 to the minus 19 coulombs per electron, and so this is not precise, but it's pretty close to being like the same number, right? If this was 1600, then it would be easy division. So I'm just going to round this off a little and say, because I don't feel like pulling the calculator, 16. So this is I'm going to say 1.62 times 10 to the third over 1.6 times 10 to the minus 19. And so that means this is going to be, n is going to be about 10 to the 3 minus 22 electrons. Okay, that's the number I think we have, and I'm sticking by that. Is that right? Yeah, well... Oh, yes, I think it is. Yes, it is. Haha, okay. Anyway, that's number 9.